Today our discussion will be on group 2 elements, alkaline earth metals. So these alkaline earth metals, we have talked about this in our introduction, the first part of the video, part 1, we've discussed even there. So today we are just going to highlight some few points. Okay, we are not going to discuss in detail. So these alkaline earth metals, they are known as alkaline earth metals because their oxides and hydroxides are alkaline in nature. Okay, and their oxides are found in on Earth's crust. Now, except for this beryllium, okay, all these have oxides and hydroxides, and they are alkaline in nature. Okay, except for beryllium. For beryllium, the oxides is amphoteric. That means it can act as base or acid. Now, group 2 elements consist of these elements: beryllium, magnesium, calcium, strontium, barium, and radium. So you can make it into one word, like Bimeka Cerbera, Bimeka Cerbera, for easy understanding. And this radium, it is radioactive, so we won't be discussing much about this radium, in the next topic also, in our next discussion also. Mostly we will discuss about these 5 elements, beryllium, magnesium, calcium, strontium, barium. Their electronic configuration, we have already discussed that, even the general electronic configurations. Ns2, the electronic configuration is ending with S2, 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 so, and can be the number of shell, any number, 2, 3, 4, 5, 6, 7, so in short cover you can add helium, neon, argon, lithium, xenon, and radon. So for this one, you can watch the first video. Now let's come here, or it can be written as noble gas, Ns2, electronic configuration. So we are going to discuss about general characteristic of group 2 elements or alkaline earth metals. Before going here, let's check few more points. This beryllium, also like lithium, this beryllium also show anomalous property than the rest of the element. That's why except for this, all are alkaline in nature. The oxides of this one is amphoteric. Now this beryllium also will show diagonal relationship with the next group, with the next group, the third group, and the third group with the second element. Now let's come here, general characteristics of group 2 elements or alkaline earth metals, or we can say general characteristics or general traits. So first one is electronic configuration. Electronic configuration I have already given here, noble gas, Ns2. So general electronic configuration will be, let's follow your textbook, it's given noble gas and then Ns2. So like alkali metals, they are also ionic, in nature, so they comes in ionic form mostly. Next point will be atomic and ionic radii. So atomic and ionic radii, we have discussed that even for group 1 element. Now for this one also it is similar, atomic and ionic radii. So atomic radii and ionic radii, the radius, from the nucleus, to the shell, so atomic radii. So atomic and ionic radii, they both will increase down the group. Okay, down the group increases. Okay, because as the atomic number increases down the group, okay, the atomic radii will also increase, and even the ionic radii. Okay, this is due to increase in number of shell also. And please note that atomic radii, okay, atomic radii will be always greater than ionic radii. Okay, so for the same element, this will be atomic radii will be always greater, like beryllium, Be. Okay, B will be always greater than Be 2 plus. Okay, so I'm writing 2 plus because in the outermost shell 2 electrons are there, so they can lose these 2 electrons. Okay, and usually they lose these 2 electrons to become 2 plus. Okay, Be2 plus or Mg2 plus, like that. Okay, so second group, they exist as 2 plus. Okay, mostly. Now atomic and ionic radii, we have discussed that it increases down the group. Now we'll compare with the first group element. So this atomic and ionic radii of group 2 element is less than the first group element. So atomic and ionic radii of group 2 element is smaller. Okay, smaller than group 1 element. So we are going to discuss about this reason also, why this one is smaller, okay, for group 2 than group 1 atomic and ionic radii. Let's take 2 examples, sodium and magnesium. So sodium is from group 1, magnesium from group 2. Okay, so sodium has atomic number 11, magnesium atomic number 12. Electronic configuration will be 3s1, 3s2. They are in the third shell, that means. Okay, so atomic number means this will be number of proton. Okay, and number of proton will be is equal to number of electron. In the same way, this proton will be is equal to number of electron. So that means it has 11 electron, okay, and 11 proton in sodium, and Mg 12 proton and 12 electron. Now if we consider the nucleus, okay, in the nucleus there is proton, okay, surrounded by this. In the shell, okay, you will find electrons. Okay, so proton positive charge and electron negative charge. So this proton will tend to pull towards the electron towards itself. So more the number of proton, more will be the attractive force. Okay, also there is shielding effect also. Okay, but if there is more proton, in this case for Mg 12 proton, then it will pull electrons more. Okay, here in this case sodium atomic number 11 and it has 11 proton. Just check, they have the same shell, third shell. Okay, so since they are in the same shell, shielding effect will be similar. Okay, the shielding effect. Okay, but since Mg has 12 proton, it will pull the electron towards itself, and then what will happen is Mg will be that the shell will come closer to the nucleus, and Mg will have smaller size. Okay, Mg will have smaller size than Na. Okay, since in Na only 11 proton, Mg 12 proton. Okay, so they have 3 shell, 1 2 3 shell. Okay, but in this electron, between electron, there is also shielding effect. Okay, this electron pulls the outermost electron away. Okay, and size increases. Okay, so as a result, this proton in the nucleus and the electron, there is less attractive force between them. Okay, since here more number of protons are there, that's why it can attract, okay, the electrons toward itself, and as a result size becomes smaller for Mg. So in the periodic table, okay, when we move down the group, atomic number increases and then shell also increases. But across the period, okay, when we move from left to right, okay, across the period in the periodic table, size decreases. Okay, and this size decreases due to effective nuclear charge. Okay, so this is known as effective nuclear charge. Okay, when the proton in the nucleus attract the electrons, okay, in the shells, okay, towards itself, then it is known as effective nuclear charge. Okay, so the reason is because of effective nuclear charge of group 2 element. Group 2 elements show more effective nuclear charge. Okay, that is why they have smaller atomic and ionic radii than group 1 element. Okay, that means attractive force between the nucleus and the electrons. And usually you will find that Na, okay, because of configuration 3s1, it will lose only 1 electron, so it will become Na plus. But for Mg 3s2, so it will become Mg2 plus, okay, by losing 2 electrons, and they have tendency to lose 2 electrons more easily. Okay, so that means in Mg, if 2 electrons are gone, then it will have only 10 electron now, and for Na, 1 electron lost, then it will have 10 electron now, but the number of proton will be the same since only 1 electron is removed here and 2 electrons removed here. So in this case 11 proton, in this case 12 proton. So this 12 proton can attract this 10 electron more easily compared to 11 proton. So Mg2 plus, okay, consequently will have a smaller size. So this is the reason. Okay, so the main reason will be effective nuclear charge. Okay, they have higher effective nuclear charge, this group 2, than the group 1 elements. Okay, so as we move across the period, the size decreases because of this effective nuclear charge. Okay, so that means group 1 elements will be the biggest, okay, among the elements. Okay, this group 1, secondly the group 2, and then group 3rd, 4th, 5th. Okay, all those will have smaller size. Okay, the size decrease. Now we'll come here, ionization enthalpy. Before ionization enthalpy, let me write the spelling. Okay, effective nuclear charge here for the upper one, effective nuclear charge. Okay, the spelling is like this. Now ionization enthalpy, let's come here. Ionization enthalpy means energy required. Okay, I'm writing in short form, energy required to remove the outermost electron from the or from any gaseous atom. Okay, so the outermost electron, okay, the energy to remove this outermost electron. So this ionization enthalpy, okay, as the size increases, that means as the atomic number increases, size also increases, shell also increases, okay, the distance between the nucleus and the electron, it will increase, okay. So there will be less attractive force between the nucleus and the electron, so less energy will be required to remove the electron, okay. So ionization enthalpy decreases down the group. Beryllium will have the highest ionization enthalpy, okay. The lowest will be barium, okay, decreases. Since beryllium has small size, electron will be closer towards the nucleus, and then there will be much attractive force between the nucleus and the electron, so high energy will be required to remove that electron, okay. So that is the ionization enthalpy. And then smaller size means higher ionization enthalpy, bigger size means low ionization enthalpy. So we are going to compare the ionization enthalpy of group 1 and group 2. Group 2, okay. I'm writing in short form. First ionization enthalpy IE of group 2 is greater than first ionization enthalpy of group 1, okay. So this first ionization enthalpy means removal of the first electron, okay, the first electron from its outermost shell, okay. Let's see the example here for group 1, okay. Group 1, sodium, okay. First ionization enthalpy, you can lose one electron to become Na plus, okay, one electron loss, okay. So atomic number 11, so one loss, so it will have 2 8, okay. Electronic configuration will be 2 8, so this will give noble gas configuration, okay. So this Na in the second, okay, second ionization enthalpy, it will lose electron, okay, and become 2 7. So if it lost 2 electron, it will become Na2 plus, okay. This will become 2 7, okay. So in this case it is not stable, okay, this ionization enthalpy. It will take higher energy, okay, to remove electron from here, higher energy, okay. Now let's see for group 2. Magnesium. First ionization enthalpy, so it easily lost 1 electron to become Mg plus 1 electron, so 2 9. Now it can lose 1 electron, okay. Sorry, it will be 8 and 1, okay, not 9. 2 8 1, okay. Second, first shell, second shell, third shell. This will be first shell and second shell. So from this second shell, it will require higher energy to remove this electron from the second shell, okay. Now here, third shell has only 1 electron, it will be easy to remove this, okay. So it will become Mg2 plus 2 8, okay, noble gas configuration. Now for this case, what happened is this one ionization enthalpy, okay, group 2 is greater, okay, for the first one it's greater, okay, but for the second ionization enthalpy, okay, second ionization enthalpy, group 1 is greater than group 2. Since here it takes, okay, it will require higher energy, okay, to remove electron from the second shell, okay. Since it has only one in the outermost, it becomes easy, okay. For the second ionization enthalpy, it becomes easy to remove this outermost electron single, okay. But here it is not exist as single but as octet 8, okay. So it will be difficult to remove this, okay, since they are stable, okay. This stable noble gas, okay, stable configuration. So when they are stable means it becomes difficult to remove. That is the reason why first ionization group enthalpy of group 2 element is greater than the first ionization enthalpy of group 1. But in the second case, the second ionization enthalpy of group 1 is greater than group 2. So the another reason can be this, or this first ionization enthalpy greater than group 1. We have discussed that group 1 are bigger than group 2 element also, okay. So smaller the element, higher will be ionization enthalpy. So from that reason, from that point also, we can understand first ionization will be always greater for group 2 than the group 1, okay. But for second, group 1 was greater, okay, than group 2. We have discussed here, okay. Now let's proceed further. Hydration enthalpies. So this hydration enthalpy means the energy involved, okay, or energy released when 1 mole of gaseous ions combine with water, okay, to form hydrated ions. So example can be CuSO4 5H2O, okay. So this 5H2O is known as hydrated, okay, water molecule, okay. So this water molecule come and attach with this, okay, CuSO4, okay. So this is known as hydrated, okay. So energy involved here or released here is known as the hydration enthalpy in simple words. So we have discussed hydration enthalpy before also. So smaller the size, okay, of the ions, higher will be the hydration enthalpies. So in this case, hydration enthalpy of beryllium, okay, Be2 plus will be the highest, Mg2 plus second, Ca2 plus third, strontium fourth, and lastly barium 2 plus, okay. So smaller the ions, higher will be its hydration enthalpies, okay. So we can say from this, okay, order, hydration enthalpy decreases down the group. Now we'll compare the hydration enthalpies, okay, with the group 1 element also. Now we have discussed that group 1 and group 2, okay, their size, okay, we have discussed about their size. Group 1 are greater than group 2, okay. So obviously group 2 elements will have higher hydration enthalpy than group 1. Since group 2 they are smaller in size. Okay, so we know smaller the size means higher will be hydration enthalpy. So group 2 will have higher hydration enthalpy than group 1 elements. Okay, from that concept we can understand. And some example of hydrated molecules, okay, are MgCl2 plus 6H2O, okay, and CaCl2 6H2O. So these are the example of hydrated molecules. Okay, hydrated molecules where water molecule is attached. Now let's come here. Okay, physical properties. Now, alkaline earth metals are usually silvery white lustrous. Okay, they are silvery white lustrous. They are relatively soft. Okay, these alkali also they are soft, and alkaline earth metals they are also soft, but these alkaline earth metals are harder than alkali earth metals. Okay, we know that they are group 2 are smaller. Okay, this may be the reason. Okay, now beryllium and magnesium they are somewhat grayish, okay, in color. Now the melting points and boiling points of these elements are higher than the alkali metals due to their smaller size. Okay, because of smaller size, their melting points and boiling points are higher than the group 1 elements or alkali metals. They are strongly electropositive in nature. So electropositive means they can readily lose that 2 electrons in the outermost shell, okay, and become electropositive. So this electropositive character increases down the group. Okay, down the group it increases from beryllium to barium. Now flame test. Okay, so when we heat this element, okay, so calcium, strontium and barium impart characteristic big red. Okay, so big red is for calcium, crimson is for strontium, okay, strontium, and barium apple green colors. Okay, so in flame test they show these colors, but Be and Mg they do not show flame test. Okay, because of small size. So when it is small, okay, that means electrons will be closer to the nucleus. Okay, and in flame test since their electrons are tightly bound, okay, near the nucleus, okay, it is difficult to remove their outermost electron, okay, or excite the electrons of this beryllium and magnesium because of their small size. Okay, that is why they do not show flame test. Usually in flame test what will happen is electrons, okay, of these elements, suppose calcium, okay, when heated, okay, get excited to higher energy state, okay, from ground state to excited state, and when they come, okay, after absorbing they move to higher energy state, okay, and after some time they will release this energy, and this energy will be visible, okay, in the visible region, and if in the visible region they will show after emission of radiation or energy, they will show this red brick color, okay, red brick color. Okay, that's why they show flame test. But for this beryllium and magnesium, the electrons are tightly held, okay, but even under the influence of this flame, these electrons they do not get excited, okay, that's why they do not show flame test.